All right, so this video is to take you through the second activity in 1.3.4, which is the screw holder. And I'm pretty much going to work through the steps as they appear on the screen in the PowerPoint and hopefully won't have any major issues with it. Who knows though? It's an adventure. So we're going to start by starting our sketch. And I literally have a screenshot of the steps on my phone, and I'm doing what you guys kind of do in class, which is I've got my phone in one hand and I'm going to design in Fusion in the other hand, and we'll see how it goes. So the first thing we need to do is to draw a pentagon. So the base of this is going to be a pentagon, and that is going to be a new skill for you. And I might do a quiz for this video also, so I'm going to take some notes as I go. Pentagon, new skill, how to draw a pentagon. Probably would have made for some better stars in our last video. So when we want to make a pentagon, we're going to drop down in the create panel and we're going to go to polygon, and you can do your polygons several different ways. Usually I will go with either a circumscribed or an inscribed polygon. So if we look at this, I can't really zoom in. The circumscribed polygon means that the circle's on the inside. So you're pretty much using a circle to center and anchor your polygon. And then the sides of the polygon are going to be tangent to the circle. So the distance from the center of the polygon to the midpoint of the side of the polygon is going to be the radius of the circle. So if that's a dimension that you want, then that's the one you want to pick. Now the inscribed polygon, the circle is on the outside and the vertices of the polygon are going to be on the circle. So the distance from the center of the polygon to a vertex is going to be the radius of the circle. So again, you want to pick whichever one of those is going to give you the dimension that you want. So whether you care about the distance from the center to the midpoint of a side or the distance of the center from a vertex. The edge polygon I don't typically use, so you select the starts and endpoints of one edge and then a distance and an angle, specify the number of sides. Haven't ever needed to do that. So that would maybe be more if we didn't want them to be regular polygons, but usually we do. For this one, I guess I'll go with inscribed polygon, I guess. And I'll center it at the origin and draw it out. And as you can see, as I make the circle bigger, and you can see now what an inscribed polygon is, maybe just for contrast, I'll do the circumscribed polygon just for those that are in geometry. Okay, so the circumscribed polygon is outside of the circle and the circle is going to be tangent, and you can see as I'm rotating that the radius of the circle will take me to the midpoint of each line, and then the inscribed one is like this. And for this design it doesn't really matter. Okay, so the polygon is inside the circle. Now I would like to have a pentagon, and if you see down there where my mouse is clicking, it says 6. So I've got a hexagon. A pentagon has 5 sides, and we could do as many sides as we wanted. So if you needed 10 sides, there's your 10 sides and so forth. But for this one, we need a pentagon. And I think I'm going to try to get this oriented on the origin and my coordinate plane in a way that I like. Now notice how when I hover over the y-axis or the x-axis, you can see that it turns color till it kind of snaps into place there. And probably, and we're not seeing it, but I'm not going to be shocked after the last video, Fusion's going to place some kind of constraint on that, which is going to make it harder for me to move it, but we'll see. Okay, so I'm going to place it right there, and yeah, so I'm just curious if it'll let me drag that. Oh, it does let me drag it, so it's not constrained there. But we do have a constraint on there, and that is probably a polygon constraint, which is constraining this to be a regular polygon. So yeah, I can't mess around with the vertex, and if I make one side bigger, like the whole thing gets bigger. So there are some constraints on there that are going to keep that being a regular polygon. So I guess I'd like to line that up. I'm going to go ahead and put a vertical constraint on that just because there we go. And that, I don't really think it's necessary, but I just kind of want to make sure that this stays oriented the right way. If you saw the picture from the video slide, my circle was just way off. So I don't know what we want to dimension this to be. Let's see. It doesn't really matter, and I don't think in the video that I just really don't think it matters. But I'm gonna make that 4 inches just to make sure that I have plenty of stuff, plenty of space to work in. Okay, so we're going to draw a pentagon, and the next step is to extrude it with a tapered extrusion of -45 degrees. So to do that, we need to finish the sketch. We'll click extrude, and we are going to, I'm actually going to turn this so I can see it a little bit better. And we haven't done this before, but you'll see it on the menu, the taper angle. And so we're being told to do this at -45 degrees. And just so you can see what that is. Okay, and you can see what that does. So we're extruding it, and we're extruding it upward at this angle. And I want some kind of base there. It doesn't tell us how far to extrude it, but 1/2 inch, sure, that seems fair enough. Sounds good. Okay, so we've got our base, and now you can see what a tapered extrusion is, and you should be able to carry that out. The next thing is to create, extrude it again with a tapered angle of -2 degrees. I don't know what we're doing with that, but okay, we'll extrude it again. And -2, I'm not sure what the point of that is. Possibly to see the difference. So, oh yeah, that looks nice. I don't know how big we want this to be, but 3 inches, sure. And notice this, we haven't really talked about this down here on the lower right, but is this operation join? That means that the base and then this part is going to be one body pretty much. So you're going to have one body. We haven't done assemblies over here where we've pulled apart the bodies. If you can see where my mouse is over there on the left, we haven't done anything like that. So, all right, so that looks great. Here's the base of that. I don't know where we're going with this. Next, create an offset plane. So that is a new skill. So a plane, for those of you that are not in geometry. Now, everybody who's in geometry, who's taken geometry, hopefully you're good to go on what a plane is. But a plane is a 2-dimensional face. You can think of like a wall, a ceiling, a floor. Okay, so you can move in 2 directions. Offset means it's away from whatever it is you're designing. Okay, and so what we're going to do is under the construct panel, we're going to pick, and just when you're doing this, take a moment and browse through the options. Plane at angle, tangent plane, mid plane, that is actually useful. Plane through 2 edges, plane through 3 points, that really gets into some of your geometry stuff. And then you can also construct an axis. An axis would be a line. So that's 1-dimensional. And you might need to put an axis through something in order to reference the center of something you've designed. In Inventor, when we did the automatas, we had to put axes through things. Fusion does not make you do that. But you can basically construct axes, and you can also put points. So if you needed to put a point in a specific spot, so you can see when I hover over the vertex there, Fusion recognizes that as a point. But what if I needed a point like in the middle of one of these? This would allow me to do that. So this time we're going to pick offset plane, and then we have to tell the program where, what do we want it offset from. So we're going to offset it from the top, and then it asks us, well, what distance do you want it offset by? And you can get that by either dragging the plane up or specifying the specific distance, but let's do 2 inches. That seems great to me. And I'm going to move this over so you can see what we did. So now we have this plane. It's parallel to the XY plane, but it's hovering above our screw holder that we're building. Okay, so that's what we've done. And you can move that plane around. And what are we doing on that? We are drawing a circle on the offset plane centered at the center of the pentagon. So we're going to start a new sketch, and I'm going to choose that plane. And ideally, if I've done this well, I will be able to center it on the center of my pentagon, because I centered my pentagon on, that still doesn't seem centered. I'm pausing because I'm thinking about, if this were a hexagon, we would be fine. But a pentagon is not symmetrical. The pentagon itself is not symmetrical around the origin. It's only symmetrical over the y-axis. And I'm just thinking, is there any way that you could draw the pentagon so that it would be symmetrical? But I'm not sure there is. So I'm just thinking is all I'm doing here. I'll pause the video while I think. Okay, so I unpaused it. What you can see that I did here is I drew a bunch of construction lines, and I got to remember to turn off the construction thing because there is no symmetry around the origin there because it's a 5-sided thing. So what I did, and you can tell this is not done perfectly because I'm drawing on that plane. Like if we turn this around, you can see like basically I've drawn on that plane. But what I tried to do was draw the perpendicular from a vertex to the side opposite to see if I could locate, I don't like how that's oriented. Hang on. There we go. To see if I could locate like the best point to put the center. And I was freehanding it because Fusion was not, like, it's recognizing these lines now, but it wasn't recognizing them when I was trying to draw them with the construction line, to try to put that circle in a better spot. So that's what I did. I'm just trying to get that centered in a better position. And now that I'm doing that, it's like triggering like a lot of midpoint things going on. But I'm going to put my center of my circle there, which is a little bit lower. I like that. Okay, that seems to work. That just seems to have worked better. Okay, so there's my circle. And because they're construction lines, we don't have to go back and delete them. If they were actual lines, we would have a problem. But notice that Fusion is not recognizing those lines as an object. So there's the circle centered in the polygon, but it's not at the origin. So that obviously didn't work. I could go back and rethink all the geometry because I'm sure there's some stuff there. It's been a long time since I've done the geometry. So the next part is to create a loft between the pentagon and the circle. So I'm going to turn this. So what we have is a pentagon down here and a circle up here, okay? And they're obviously different shapes. And what a loft is a loft will create a smooth surface to go from one to the other. So it's going to start as a pentagon and then end up as a circle. So to find that, we're going to go into the Create panel, and we've already looked at extrudes, revolves. We haven't done sweeps yet, but we will. We're going to do a pipe. That's going to be our lesson for the sweep. We're going to look at loft. And again, as Fusion is so good about doing, it kind of shows you, hey, this is what a loft does. When I made my lighthouse, when I did my training, I did a series of lofts because what I needed was for the loft, the lighthouse to get narrower as it went up to the top, but I also wanted to be able to change the color of it in different places. So we're going to go ahead and construct that loft, and it's going to ask you for your two profiles. So we would like the hexagon to be one, and we would like the circle to be the other, and it gives us that nice little preview. There are different guide types that you can use. So you can guide it with the center line, guide it with the rails. I don't think we have a center line. Yep. So we'll leave that as is. And there's Oh, a cat just, you can't be there, cat. Just one of the most inconvenient places. Okay, so what we've done is it kind of morphs that into this nice smooth transition between the pentagon on the bottom and the circle on the top. The next thing that we need to do is extrude the circle upwards at an angle of -2 degrees. So I'm sure we'll do that. So we're going to extrude from here. We want this taper angle to be -2 degrees, and nothing is specified here. Let's do an inch. Sure, an inch seems good. Okay, and then the next piece of the direction says fillet the edge of the top. So we'll pick our fillet tool and pick the edge. Make sure you're not picking like a face or something. We're going to pick that edge. And I don't know what kind of fillet we have on that. Let's oh, that maybe is a little extreme. Let's do like 1/10 of an inch fillet. Yeah, kind of like that, just to make it nice and roundy. And there we go. And so, oh, my phone just went quiet there. Extrude a hole in the center that goes almost all the way to the bottom. So we're going to need to do a sketch. And I think I can use the center there. So let's go ahead and put a hole there. And this, I think this would be like for the screwdriver or something. I don't know. There we go. And we're going to finish that sketch out and do an extrude. And we're going to extrude it in, but not all the way through. So we don't want it to be going down there. Okay, so almost all the way through. 6.5 inches. Let's just make sure that that did not poke through the bottom. It did. We do not want to extrude it that far. 6 inches. Let's check it out. I think we're okay. Yep, we're okay. All right. So that looks pretty good. And notice the operation there is cut. We're doing a cut and we did not poke through the bottom. So that's great. And then the last part is to use a circular pattern to create 5 more holes that only go part way down. And so we're going to create a sketch again on this top part. I'm going to use this. I haven't paid any attention to the size of the holes, but that looks pretty good. Does that look about good there? Oh, come on. That was a cat that did that on it. I swear it was a cat that did that. Like 5 holes. I really don't like where the measurement is because I can't see the top of the hole. Yeah. I'm gonna move it a little bit. It's a little bit too close to the edge. We're gonna move it there. That looks pretty good. Okay, and to do this, we're gonna do a circular pattern. So in my create drop down, we're gonna pick circular pattern. It's gonna ask us what we want to pattern. We would like to pattern that circle around that center hole. Oh, oops. Wait, shoot. I picked more things than I wanted. There we go. Just the circle picked it. And we want it around the center hole, and we would like 5 of them. There we go. And we're going to extrude these down. Oh, we have to finish the sketch. And we're going to extrude those. And because there's all the same extrusion, we're going to pick all 5 because we don't want to do 5 extrusions when we can get away with just doing 1. And this is only part way down. Okay, so like 3.5 inches. Okay, and that's pretty much the screw holder. So we've got different size holes. Now the last thing, if I pull this up on my phone, is to shell the part. And to shell the part is exactly what it sounds like. You're gonna like dig out all the material from the inside. And what you specify when you do a shell is you specify the width of the outside. So this is our shell, and you pick the faces, like the direction that you want to shell it from. And so this, we would want to shell it from the bottom. And then it says the inside thickness. So we can probably play around with that a little bit. Whoop. Oh, notice the error. It says the operation does not cause a meaningful shape change. Try change. Oh, now what's happening? Fusion is not responding. Seriously? Okay. I can pause the video while we wait for this to sort itself out. Yay! I'm glad I had the option of pausing the video because that actually took a while. Took a while for that. So with your shell, like you can specify the inside thickness, and it's obviously like not, it's giving me that error because if the inside thickness is 5.5 inches, it would close in on itself. So let's do an inside thickness. Move my cat's paw off of them. Of say 0.2 of an inch. And what you can see is that tells you like how thick that shell is, and you can look around at it. So you can actually see the holes that we extruded. It's gonna shell around that, and you can see that one of them comes almost down to the bottom. The others are only part way down. This would definitely help you save money on costs. It obviously is also going to affect like the stability, but it depends on, you know, whether that matters. So we could shell it a little bit thinner. I think I like that a little bit better. That's 1/10 of an inch shell on that, and then we'll select OK for that. Now for your submission, what you have to do for a screenshot for this, you have to do the isometric like so. So you have to do a screenshot of that. You have to give a screenshot of the bottom of it so that I can see what's inside. And then you also have to do a section view screenshot. So to do that, we go, and I think we've done this a little bit. I just can't remember if I've done it with individual students or whether we've talked about it as a class. I think it's, we're going to look at section analysis. And it's going to allow us to cut into the figure with a face. And probably like all of these faces are going to be a little bit tilted in because they all had a taper angle on them, but one of your faces should work, and you're going to slice into it in such a way that we can see the inside and you can see that shell thickness. And so then you'll turn it around and you're going to take a screenshot of something like that. You may not use my screenshots, okay? So I was really specific in this video about the dimensions and the numbers and the things that are on the screen. If you show me my own work, so help me, I am not going to be happy with you. So don't do that. But that's going to be your third screenshot for the screw holder. And that completes this demo video on the screw holder.